talked yesterday about solving equations based on looking for the sides. Now we are going to solve for missing angles. That's the other benefit of being able to use these trig equations, is that we can set up and solve for missing angles, which we have not been able to find before until now. Okay, so remember your steps. You want to label O, A, and H so that you can decide whether you're using sine, cosine, or tangent based on SOHCAHTOA. Then you set up your equation following that pattern that we learned in the beginning, and then you're going to solve. Now this is going to be a little bit different today than it was yesterday. When you solve for a side, you either multiplied or divided by the ratio depending on where your variable was. Again, I want to remind you, you need to make sure that your calculator is set in degrees. There are 360 degrees in the circle, or there are 2 pi radians. In geometry, we use degrees. So go to mode, and you want to make sure that it is in degree mode. So you'll go down, and there is a radian degree line. If you will go over and highlight degrees and click it, then you will be in degree mode, and your calculator will behave the right way. Just a reminder, if it's in radians, you will get funny answers, like teeny tiny or small decimal answers or negatives sometimes. And so that'll be your hint that you are in the wrong mode. So just always double check that, because sometimes when the calculators get reset, that goes away. All right, so same pattern. We have been doing the same thing. We're just going to add one small thing here. First thing, label O, A, and H based on where the angle is. You have angle X. 6 is opposite, and 15 is adjacent. That means that we will be using our tangent function. So we set it up. The tangent of the angle is equal to the opposite side divided by the adjacent side. Okay? Now, here's where it's different. Before, we were able to just multiply. Remember, the tangent of a number is a number. It has a ratio. The tangent of 45 is 1. Okay, so you want to make sure that you understand that, because what it's going to do is, when the variable was on top, we performed the inverse of multiplication, or the inverse of division, and we did multiplication. When the variable's on bottom, we did the inverse of division or the inverse of multiplication and did division. Right? And so this time the problem is tangent. This is usually a number. Now, what we would do in the past, like I said, is we would go over here, we would find out what the decimal is for 6 over 15, and we would go over to the trig table. In fact, I wanted to show you. So 6 over 15, let's just look this up. Let me show you how we used to do it. 6 divided by 15 is 0.4. So we would go to the table. This is a tangent function, and here's what the tables look like. And we would say, okay, we need a tangent that's 0.4 because it was a tangent function in the problem. So we would go down our problem. We would go down this table right here until we found a tangent that had a 0.4. So this was pretty close. This was as close as we could get, because then it's 0.425, so 0.4040 was pretty close. And we would say that that angle is approximately 22, okay? So according to the table, that angle is approximately 22 degrees. Now, what has happened is somebody has taken all of that information from the table and they've put it in these little fancy calculators, okay? And so we didn't have these fancy calculators when I learned how to do this. So what we wanted to do is we were using the table backwards. So we would go to the table to then find the angle. We were inverting. We were using the inverse. So here's what we're doing mathematically. We are taking the inverse tangent of the tangent of x because I want to separate the angle from the tangent. We're asking ourselves, what angle had a tangent of 0.4? Well, if I take the inverse tangent of one side, I have to take the inverse tangent of the other side. So this side would also be the inverse tangent, but it would be of 6 over 15 because that 6 over 15 was there. So I'm taking the inverse tangent of the tangent of x, and I'm taking the inverse tangent of 6 over 15. Now on this side, here's what happens. The inverse tangent and the tangent
end up canceling each other out, kind of like when we talked about what happens when you square a square root of 3. The square and the square root cancel each other out, and you're left with just 3. Okay, same thing. The inverse tangent cancels the tangent and leaves you with x is equal to. So x is equal to the inverse tangent of 6 over 15. Well, up until now, we haven't used an inverse tangent key on our calculator. So let's go back to our calculator. If you noticed, above your sine, your cosine, and your tangent keys, there is a sine to the negative 1, cosine to the negative 1, and tangent to the negative 1. That is our inverse sine, our inverse cosine, and our inverse tangent. So when you are solving a problem like this and you want to do the inverse tangent, then you simply hit anything in blue, you use the blue key to get to. So you take the blue key to get to the inverse, the shift key, and then the inverse tangent. So you would hit the tangent key. Notice it says tangent to the negative 1, just like my problem does. And then you type in 6 divided by 15, just like it says. And then you hit enter. And we get 21.8. Well, my table said 22 degrees. The actual 21.8, well, and some change, right? That's 21.8 rounded. It's pretty close to 22. So the table is close, but it's not exact because we don't have all those decimals in between. It was just whole number decimals, or whole number angles. So that's how we used to do it with the table. And I just kind of wanted you to see because I thought it might help you to understand how we're using the table backwards. Used to, like when we found the angle, we could say, okay, the tangent of 81 is 66.3138, and then we would use that to multiply to find our missing side. Well, this time we're starting in the tangent, so sine or cosine column, and we're finding out what the angle is. So we're inverting, or we're doing that the opposite of what we normally would do. Okay, so you won't have to do that. You won't have to use that, but we are going to, I just wanted you to see that inverse operation. So everyone's going to work the same way. We have our angle. 15 is opposite of our angle. 40 is the hypotenuse. Don't get that confused with adjacent. Always find that. Okay, O and H, that's sine. So the sine of the angle is equal to the opposite side divided by 40. We are looking for the angle, so we are going to inverse sine. So x is equal to the inverse sine of 15 divided by 40. And you would type that in on your calculator. Okay, we need the inverse sine, which is above the sine key, inverse sine 15 divided by 40. And you get 22.02 degrees. 22 degrees. Okay. Number 3. 8 is opposite, and you might need to get that hypotenuse out of the way so you don't confuse it with adjacent. 17 is adjacent. So I am using opposite and adjacent, that's tangent. The tangent of the angle is equal to the opposite side divided by the adjacent side. You're going to inverse tangent to be able to find out what that angle is. So inverse tangent of 8 divided by 17. Type that in. Inverse tangent, because you need the tangent to the negative 1, of 8 divided by 17. And you get 25.2 degrees. Okay, and they're the same every time. All you have to remember is that you have to take the inverse of it. Okay, that's my hypotenuse, so get it out of the way. 7 is adjacent, 12 is opposite. That's O and A, that's tangent again. Tangent of the angle is equal to opposite divided by adjacent. Remember, we're taking the inverse of this side, which makes the tangents cancel out and leaves me with x. Let me write that down so you can see it, right? We're taking the inverse tangent of tangent, which those cancel each other out and leave us just with the x. And then we're going to take the inverse tangent of this side. So the inverse tangent of 12 divided by 7. Notice on your calculator, it automatically, inverse tangent, It automatically opens up a parentheses for you. Then you just type in 12 divided by 7, and you can close it or not. It doesn't matter. If you're going to do more with it, then you would need to close it for sure. You get 59.7 degrees. Just be careful to round to whatever you're instructed to round to. Now, this one you have x and y. And the thing is, it doesn't matter which one you do. You can do either one. But it does, once you have to decide first, because 8 is opposite of y, but it's adjacent to x. Okay, so it doesn't matter. I'm going to use to x, so this is the angle I'm going to use. 8 is adjacent to x, and 20 is the hypotenuse. That means I'm going to use the cosine of x. The cosine of x is equal to the adjacent side over the hypotenuse. That means that the cosine is, the angle is the inverse cosine of 8 divided by 20. So inverse cosine of 8 divided by 20 is 66.4 degrees. Make sure you test it. Make sure you type that into your calculator so that you can make sure you get the same answer that I do. Now you can get y a couple of ways. You can go back and you could do y, just to show you it doesn't matter. Y is, 8 is opposite of y, so that would be opposite in hypotenuse, that would be sine. The sine of y is equal to 8 over 20. Inverse sine of 8 divided by 20. Inverse sine of 8 divided by 20 is 23.6. Look at these two. Do you notice what they do? They add up to 90 degrees, right? And that's what they should do. These two are complements of each other. So you could have, if you trusted this answer, you could have also taken 90 minus 66.4 and gotten that 23.6 also. So if you trust your previous answer, you can use it to get your next answer. If you don't and you're not sure, then use the other trig function and make sure that those two add to 90 degrees the way they're supposed to. We can do the same thing here. If I use x, this is adjacent, this is hypotenuse. The cosine of x is equal to 18 over 70. I want to take the inverse cosine of 18 divided by 70 is 75.1. I trust that I did that correctly, so if I take 90 and subtract 75.1, I get 14.9. And if I were to do the inverse sine of 18 over 70, I would also get 14.9. Occasionally, you might have a little bit of an error based on rounding. That can happen sometimes, but it won't happen often. So to solve for missing angles, we set up the equation exactly like we always have, but this part is different. Isolating that variable requires that you do the inverse. And this time we're trying to get that angle separated. What angle? And I don't want to sit and test all of the angles. I want to just be able to find it. And so instead of testing them all, I just take the inverse tangent. And I find, or the inverse sine, or the inverse cosine, whatever it is. But it's the same step every time. Set up the equation, take the inverse if you're looking for the angle.